Hereby, I open this academic ceremony in which Thorben Aussieker will defend the academic thesis, The Anabolic Effects of Collagen Protein, a Muscle Perspective. May I invite you to present a summary of your study and the conclusions of your thesis?
Sure. Dear Pro-Rector, committee, family and friends, and of course colleagues. In the next 10 to 15 minutes, I'm going to present a short overview of my PhD research I conducted over the last 4 to 5 years, entitled The Anabolic Effects of Collagen Protein, a Muscle Perspective, or in Dutch, de anabole effecten van collageeneiwit, een spierperspectief. So muscle is made from proteins, and these proteins are constantly being built, which is called protein synthesis, but also broken down, which is called protein breakdown. And the building blocks for these proteins, for these muscle proteins, are amino acids. The main process we're focusing on today is protein synthesis, therefore the buildup of new muscle proteins. However, it's also important to mention that muscle is not a uniform tissue. It's composed out of different types of proteins. So if we have a closer look into muscle, there are two major components. One is the contractile tissue, basically producing force. And on the other hand, we have connective tissue, which is transferring the force to the tendon and ultimately to the bone, and therefore allowing movement. And only the combination of these two allows proper movement to allow performing daily activities, but also sports. So only if both of these fractions, both of these tissues, proteins, are functioning well, we can have proper functioning. To measure muscle protein synthesis, we infuse participants with so-called tracers, which you can see here as the yellow circles. By taking blood samples, we can measure the concentration of these tracers in the circulation. And with the use or collecting muscle biopsies, we can measure how much of these tracers are actually being built into the muscle. And then if we take these muscle biopsies, we take that to our laboratory and we separate that into the contractile tissue of muscle and the connective tissue of muscle. All these measurements can be performed in the rested state. That basically means like you're sitting on a chair or laying in a bed, or also after performing exercise, which we call the exercise state. And to measure an increase in muscle protein synthesis, we first need to stimulate it. And for this, we have two anabolic stimuli for muscle, which is exercise, but also nutrition. And for nutrition, it's mainly protein, usually in the form of eggs, meat, but often also as milk protein. And it's well known that both of these anabolic stimuli can stimulate the synthesis of the contractile tissue within muscle. While connective tissue can be stimulated by exercise, it seems like it's not responsive to dietary protein. So we need to consider that connective tissue is built a bit different. So the main building block of this connective tissue is usually glycine. And the content of the amino acid glycine is usually quite low in most of dietary proteins, like milk protein, for example. While on the other hand, in collagen protein, the amino acid glycine is the most abundant amino acid. Therefore, the main question of my PhD research was to investigate whether the ingestion of collagen protein, therefore increasing the availability of glycine, can ultimately stimulate connective tissue protein synthesis within muscle. And for that, we conducted a couple studies I'm going to present now. So the first study we conducted, the participants came to our laboratory and first performed an exercise session. And then immediately after that exercise session, they either ingested just water for the so-called placebo control, milk protein, or then as the main study or main outcome of my thesis, collagen protein. Let's first have a look at the amino acid glycine in our blood, so in our circulation. And not surprisingly, as expected, after the ingestion of water, there was no change in the concentrations of that amino acid in our circulation. After the ingestion of milk protein, we also did not see an increase of glycine. On the other hand, if we ingested, or if participants ingested collagen protein, we actually saw a substantial increase of glycine in our blood. But then the question is still whether this increase of glycine has an effect on the muscle itself. So for that, we again took the muscle biopsies, we separated into contractile and connective tissue. So first, we have a look at the contractile tissue within muscle. And here we saw that milk protein ingestion actually increased the synthesis of the contractile tissue, while there was no additional effect of the ingestion of collagen protein. But then to the main outcome of that study, we also looked at the synthesis of connective tissue, where we saw, it seems like milk as well as collagen protein increased the synthesis. However, after performing statistical testing, so basically performing mathematical calculations, we can state that there's no difference between the groups for connective tissue protein synthesis. So a potential effect of collagen protein has been linked to the availability of the amino acid glycine. However, it has also been suggested that collagen or collagen protein contains bioactive peptides that have a direct effect on protein synthesis of the muscle. So we performed another study where participants again ingested just water as our control, collagen protein as in the study before, or a free amino acid mix which contains free amino acids and therefore definitely no so-called bioactive peptides. In that study, we measured muscle protein synthesis rates in the rested but also in the exercise state. So also for that study, we first have a look at the contractile tissue protein synthesis, and here first in the rested state, where we did not detect any differences between the three groups. And then we also look at the exercise state, where we first of all see a nice increase of synthesis rates due to the exercise that has been performed, but we do not see any difference between the three groups. So next, we also have a look at the connective tissue, where also here we do not see any difference between the three groups. While again, exercise strongly stimulated connective tissue protein synthesis rates, and also here with no effect of either of the treatments. So it is still known that athletes often consume milk protein after performing exercise to support their muscle recovery. But there's still the case that milk protein is still low in the amino acid glycine. So therefore it has been suggested that, for example, milk protein can or should be ingested together with collagen protein. So in the next study, we actually combined milk plus collagen protein. Well, before running that study, it wasn't really sure how much of each protein we need to ingest or how we should combine it. So we first conducted a study where we only looked at effects on the bloodstream. So in that study, no muscle biopsies were taken. All participants performed exercise, and they either ingested only milk protein, so no additional collagen protein has been added, or the addition of 5 grams of collagen protein to 25 grams of milk protein, 10 to 20 grams, or 15 to 15 grams of protein. So all groups received 30 grams of protein, just a different ratio of proteins here. So here we first look at the availability of the amino acid glycine in our bloodstream. And here it's the case that we actually see a negative availability after the ingestion of only the milk protein. Well, the more collagen we added to the drink after the exercise session, the more of the amino acid glycine became available. So there are more amino acids in protein, but also floating around in our circulation that are of importance. So next, we also look at the essential amino acids. And here, it's more or less the other way around. So the more milk protein that was present, so only milk protein, the highest availability of those essential amino acids were present. And the more collagen protein we added, the lower the availability of essential amino acids became. So from this study, we concluded that potentially the optimal ratio of collagen and milk protein might be adding 5 grams of collagen protein to 25 grams of milk protein, as it prevents a decline in plasma or blood glycine availability, and it also still provides substantial, so large amounts of essential amino acids. So this protein blend we just identified had still to be tested on muscle. So also here we conducted another study, again taken with muscle biopsy at this time, and compared the ingestion of water to the protein blend consisting of 25 grams of milk protein plus 5 grams of collagen. So in that study, again, participants were tested in the rested, but also in the exercise state. So here, like in the previous studies, we first look at the contractile tissue within muscle. Again, in the rested state first, where we actually saw an increase in contractile tissue protein synthesis rates after participants ingested the protein blend. And also here, exercise stimulated those synthesis, but the blend had a further effect, so it further stimulated contractile tissue protein synthesis. So also with that study, we look at the connective tissue within muscle. So also here, first in the rested state, where we also showed that the ingestion of the blend actually increases connective tissue protein synthesis, while exercise, again, stimulates the synthesis, but there's no further effect of the protein blend. So in short, the conclusion from my PhD research are that exercise strongly stimulates contractile as well as connective tissue protein synthesis within muscle, that the ingestion of collagen protein alone does not stimulate muscle protein synthesis, and that a blend containing milk plus collagen protein stimulates contractile as well as connective tissue protein synthesis. So with this, I'd like to thank you for your attention, and I would like to give the back word to the pro-rector.
Thank you for your presentation. You were relatively short, but that makes that we have a lot of time for the opposition. The opposition will be opened by the chair of the assessment committee of your thesis, Professor Goossens, Professor of Cardiometabolic Physiology of Obesity at Maastricht University.
Thank you, dear Pro-Rector. Dear candidate, I've read your thesis with a lot of interest, and I must say it took me quite some time. And it was not because of your writing style, but because of, I think, the longest acknowledgement section I've ever seen in a thesis. If I'm not mistaken, it was 12 pages long. And I think you set a new record in that regard. But it's, of course, very important to also thank the people for their contributions. And with the help of many colleagues, you performed a series of well-controlled human intervention studies to investigate the effects of intake of collagen protein, hydrolyzed collagen peptides, and whey protein on amino acid profiles, and also myofibrillar and muscle connective protein synthesis rates under different conditions, postprandial conditions and recovery after exercise. And several manuscripts have already been published, and I'm very confident that the others will follow very soon. So I would like to congratulate you as well as your supervisors with this achievement. And I think now there's time for some questions, of course, as usual. And I would like to start with the results you described in Chapter 2. There you performed a double-blind placebo a double-blind parallel group study in which you compared the capacity of whey and collagen protein ingestion to stimulate myofibrillar and muscle connective protein synthesis rates following recovery of an acute bout of resistance exercise. And as expected, you found a marked and more pronounced increase in plasma glycine and also proline after 30 grams of collagen protein compared to whey protein. But you did not observe, as you also showed in your presentation, the increase in glycine after whey protein intake. And if anything, there was even a modest reduction. So my first question would be, how do you explain that it does not go up, glycine or proline, and it even goes a little bit down?
Yeah. Dear highly esteemed opponent, thank you for your question. And of course, thank you for all the nice words. And definitely thanks to my supervisors as well with this. So you asked why there was no increase of plasma glycine after the ingestion of especially milk protein. So first of all, milk protein has basically no to just little amounts of glycine. So before running that study, we already expected that it doesn't really increase glycine concentrations, and we knew from previous studies that it actually decreases glycine concentrations. And that might be due to the case that it increases protein synthesis rates, and therefore glycine being in our circulation is needed to build new proteins within muscle or other structures.
Okay, so this is also not compensated because in Chapter 7, your general discussion, you did some nice calculations also about endogenous glycine production. So that cannot happen during the postprandial phase, or that it can compensate?
I'm quite sure that it can happen, that the glycine is endogenously synthesized. However, it's a fairly slow process, and therefore I think it might be beneficial to provide additional glycine.
Right. And despite this pronounced increase in glycine after the collagen protein intake, you did not see anything on connective protein FSRs. And can you briefly comment on that? I think you nicely described it in your discussion, but just some initial thoughts, how to explain that? Yeah,
first of all, we definitely expected that at least one of the nutrition groups actually increases muscle connective protein synthesis rates, which was, after statistical testing, not the case. So it might be that, for example, whey protein is lacking the correct building blocks, for example, glycine, while while collagen protein actually can deliver those amino acids, but it's lacking essential amino acids. And that's basically what led us to chapter 4 and 5.
Right, because if I'm correct, and you can correct me if I'm wrong, but after collagen protein ingestion, I think non-essential amino acids went up like, 30-fold. Glycine levels went up to approximately 1,000 micromoles per liter, if I'm not mistaken. But when you have these results, I would say, why perform further chapters, further studies with different levels, even less collagen? It's the combination, or did you really think that it would do anything? Because glycine levels in the other chapters, the studies that you did, went not up that high, right? 2,000 micromoles.
Yeah, for example, if you look at chapter 4, where we compared the different ratios of whey and collagen, we again showed that the ingestion of only milk protein or whey protein in that case decreased glycine concentrations or availability. Therefore, we again speculated that this negative availability or decrease in concentrations might be a limiting factor. Therefore, it was our idea to combine milk plus collagen protein.
Okay, so you really think we need to whey in addition to collagen? Maybe.
Exactly. So we think it's the combination. So therefore, what we call the protein blend.
Okay. Zooming in on the results in chapter 2, and in particular, I would like to go to figure 2.6 on page 35, I think. Yes, because there you show the muscle connective protein FSRs.
Yeah.
So page 35, figure 2.6, and especially panel B, the muscle connective protein FSRs. And you conclude based on those data that whey protein does not significantly increase muscle connective protein FSRs.
Yeah.
If I look at the data and if I compare whey protein to placebo, I do see that it's approximately 25% increase. And yeah, my question is actually, are you really sure, or is this just a power issue?
Yeah, it's definitely a good question. So we actually performed additional analysis to combine the two nutrition groups, which showed us that nutrition can have an effect on muscle connective protein synthesis rates. However, based on just the individual groups, we did not see a difference. I also performed t-tests, just comparing whey, for example, compared to placebo, which also there did not show the effect. So it can always be a power issue. However, we performed a priori sample size calculation, which should lead us to a sufficient amount of participants. But yeah,
sometimes you see that. But I also saw that variation in the other chapters, right? And even ranging from 0.02 up to 0.15% per hour, the individual variation. So is it a measurement error, or is it biological variation?
It's I would highly state that it's biological variation.
Okay, that's interesting, because that might have implications also for your study design. And this was a parallel group study. In some of the chapters you performed a crossover or a unilateral exercise. So what would be the best design for these kind of studies? Because maybe you would have seen significant effects in this chapter if it would have been a crossover design, for example.
Yeah, that's correct. So we performed in chapter 4, we performed a crossover study. However, that was only conducted on blood parameters. So we didn't take any muscle biopsies, so we also didn't infuse any stable isotopes. So it would be nice to do also, or to measure muscle protein synthesis in a crossover design. However, that could also lead to some other problems. For example, like the tracer you infused in the first test day still remains inside the body, and you just want to see a steady increase of the tracer incorporation into the muscle, which might be limited or difficult in that case.
Okay, would there be, a longer washout period? Would that be the solution then? Or how long will the tracer remain in the circulation to get to sort of, very low background enrichments?
So if we want to receive low or basically no background enrichments, we usually tend to go for at least 9 months to up to a year, which is not really feasible in conducting these kind of studies. However, it has been done before to run these studies in a crossover design, which still leads to good results. So it can still be done, and maybe it will be done in the future. However, for this, we first choose for parallel design to have a more feasible and straightforward testing.
Okay. And with respect to the unilateral exercise study design, would there be any disadvantages of that? I mean, is the non-exercising leg also affected to a certain extent?
So we, from previous studies, often it's shown that there's no carryover effect. However, in, for example, chapter 3, we actually showed that even in the postprandial period in the placebo group, there's an increase. And that might be due to a carryover effect, but it could also be due to circadian effects.
Okay, that's interesting. I wanted to hint at that. So that might be, but the crossover design, I think you nicely explained why that might not be a very good option. If I have time for another question, Prorector, yeah. So in all studies you examined the effects in healthy, young, lean individuals, men and women. And my question is actually whether you would expect different outcomes on maybe especially connective protein FSRs if you would perform several of these studies in older individuals or metabolically compromised individuals.
Yeah, definitely a good question, and definitely something we also discuss, and something that might be interesting to conduct in the future. As I think, or like we know that especially older people or clinically compromised people often show lower muscle protein synthesis rates, or in general protein synthesis rates. So it might be that they're even less responsive to dietary protein and therefore also potentially to dietary collagen. So I assume in elderly people, they would show even less of an effect. While in most studies, I did not show too much of an effect. So I think in terms of outcome or results, it might lead to the same conclusions.
And could it be that collagen content or composition is different in older individuals or clinically compromised individuals, rather than just, the amount that you provide and the effect that it has? If composition or content is different, you might also expect different outcomes, right?
Yeah, so it's the case that older people or clinically compromised due all kind of conditions, that there's a build-up of collagen inside the muscle, but also other structures inside the body, which is not really a positive thing. So it can actually be a negative thing. But I don't think that the ingestion of additional collagen has an effect on the build-up of this kind of collagen.
Okay. I'm happy with the questions. I would like to, with the answers, sorry. And I would like to give the word back to the Prorector.
Questions were also good.
Thank you, Professor Goossens. The opposition will be continued by Professor Prompers, Professor of Organ-Specific Metabolic Imaging at Maastricht University.
Thank you. Dear candidate, first of all, I would like to congratulate you and also your team on this rigorous piece of work. You didn't give up after, never negative, but I read it with great interest. And then I passed it straight to my son, who has recently also added collagen to his ever-growing stack of supplements. I suspect that it is due to a TikTok hype rather than solid science, so it was really refreshing to see stable isotope tracer data separating fat from fat. I still have some questions, though, and the first is about your tracer methodology, so I'm not really familiar with that. So you used primed and continuous infusion of specifically labeled amino acids. And my first question would be, why specifically those two labeled amino acids, so the phenylalanine and tyrosine?
Yeah. Dear highly esteemed opponent, thank you for your kind words and of course for the question as well. So there's large amount of tracer available out there. However, we choose especially phenylalanine as a tracer as it's an essential amino acid and usually not that prominent in other protein sources. So we don't have a washout by other proteins.
Okay. And so the phenylalanine, that's I see also results of that, but in the methods you also described the use of deuterated tyrosine. So, but I didn't really see it back in your results. Can you explain what was the purpose of that?
Yeah, we infuse with D2 tyrosine as well, as it's the metabolic process of phenylalanine. So phenylalanine can be broken down or transformed, synthesized into tyrosine, and you could perform additional analysis depending on how much of tyrosine is being broken down from the phenylalanine. However, in these studies, we did not see that benefit. Therefore, no additional analysis have been performed in that case.
Okay. So both phenylalanine and tyrosine, or well, actually phenylalanine is only a minor constituent of collagen. So yeah, with the tracer that you used, what are you then actually measuring in connective tissue?
So it is true that collagen has barely any phenylalanine in it. So we do not measure the actual incorporation of the dietary protein we take into the tissues. So we really focus on how much of the tracer we infuse is being incorporated into the muscle. So the 13C phenylalanine. And by providing additional protein, it is suggested or hoped that there's an increase in the incorporation. However, we do not measure how much of that collagen we provided is being built into the protein, into the muscle protein.
But would that be of interest in your studies? Would it be?
It would be of high interest.
So if you were to repeat your research with a truly collagen-targeted tracer, what would you then pick? And okay, well, maybe first.
Yeah. So the ideal way would be to produce intrinsically labeled collagen. So basically have collagen powder or collagen a product that has the tracer in it. However, for that you need to get a collagen source, usually from animals, that were infused with tracers. And for that we actually tried that, but we weren't able to produce intrinsically labeled collagen. So it was unfortunate. We tried it. We wanted to do a study like that, but it didn't happen at the end.
Okay, and as an alternative, if you would be able to use labeled glycine, for example, would that also help in your?
That would also be an option, and that's definitely interesting if you look into the collagen within the body, as glycine is the most abundant amino acid in that. So we might see a greater enrichment in these structures and maybe even get a better signal. However, like you read chapter 6, where we actually showed that also glycine is not that much higher, or the content of glycine is not that much higher in the connective tissue or connective protein fraction. Therefore, I would still think that it would lead to the similar results and wouldn't add too much of a benefit. It could be a benefit if you directly measure a collagen-dense structure. So there it might be of benefit.
Yeah, like tendons or something.
Exactly.
Okay. Yeah, well, this is actually a nice bridge to chapter 6, where you show that indeed only about 5% of the isolated connective protein fraction is collagen. So this low proportion of collagen in connective protein tissue, does that also limit the sensitivity of your method to detect collagen-specific response? Or?
Yeah, that's very likely, or it could be the case that due to the fact that the connective protein fraction within the muscle is not that abundant in collagen, that it's therefore not really responsive to the ingestion of dietary collagen. However, I think that's not making the studies putting them in any bad light, because we primarily focus on the muscle connective protein fraction and not collagen per se.
Yeah. And then, so the choice of outcome measure in your study. So I was wondering, reading all this, in the end, is connective tissue protein synthesis, is that really the best thing to look at, or should we maybe look at the composition of the connective tissue, or the quality, maybe mechanical properties, or?
Yeah, I strongly agree. That it would be interesting to look at other parameters, especially the mechanical properties. However, that's fairly difficult in living humans, so we can't really perform in vivo measurements of these properties. So therefore, we choose the synthesis to get an idea of how well those tissues are responding to dietary strategies, without taking too much of a tendon, for example.
But would you be able to? I mean, you took biopsies, right? Would you be able to examine something about mechanical properties from tissue from a biopsy?
Yeah, so you could isolate single fibers. However, those are fairly small or fairly short, and I'm not an expert in that field, so I can't give you the perfect answer in this case. However, I think it can be done, But still, based on our studies, which are performed in the acute setting, I do not think that you would see any differences, because to increase or change the mechanical properties of muscle fibers or other structures within the muscle, I do think that it takes some time. So it would only work in longer term training studies, for example, or nutritional interventions.
Yeah. And so your thesis focuses a lot on sports, athletes, but can you maybe, are there any conditions where where impaired collagen synthesis leads to muscle connective tissue dysfunction, and can we learn something from those conditions?
I think they're, like I'm not a medical doctor, focusing on the conditions behind connective tissue dysfunctioning. So like right on spot, I'm not aware of like any specific diseases that might be that we could target with that. However, I think that there's also other processes involved in that. So in some kind of conditions, it might be the dysfunctional buildup of collagen, while we focus on like providing an exercise support after sports.
Okay, thank you. I'm satisfied with the answers, and I give the word back to the prorector.
Thank you, Professor Prompers. The opposition will be continued by Professor De Rave, Professor of Muscle Physiology and Sports Nutrition from Ghent University in Belgium.
Thank you very much. You're doing very well. You're halfway through. Thanks a lot for the invitation. I'm really honored to be here in this prestigious university and aula. I really enjoyed reading your work. I believe what you show, and I think it should not be underestimated how much work is in here in these pages. I'd like to elaborate a bit on this limiting availability. So some amino acids seem to be like in a limited availability status. Some Lego blocks are out of stock, you could say. Did you challenge the demand, or did you increase the demand of the amino acids enough with your design?
Dear highly esteemed opponent, thank you also for your nice words, and I agree, it was lots of work, but it was also fun. And thank you for your question. It is definitely a good but also tricky question. So what we focused mostly on was, as we already previously talked about, was glycine, which is the main amino acid in collagen, but again, the muscle connective protein fraction might not be that enriched with collagen. So just focusing on the muscle might not increase the much higher increased need of glycine. So there might be other structures.
But did you increase the demand in all your muscles?
I do think that we increased the demand as we increased myofibrillar as well as muscle connective protein synthesis rate. So the body was definitely in need of more amino acids to build up new proteins.
Not exactly already where I want you to go. For example, if you would study an intervention that increases the cardiac output, and you would ask whether the cardiac output is limiting, you would increase the demand in your whole body to a level that the demand becomes higher than the supply. Would that reasoning also apply to your findings? Did you increase the demand enough to question the supply, or to challenge the supply sufficiently with only one? Well, I'll bring it to you, one exercise.
Yeah.
Right?
I hope I get in the right direction you were aiming for. So actually, in that case, I think we did not increase the demand by enough, as we even see increased myofibrillar as well as muscle connective protein synthesis rates in the placebo groups that did not receive any dietary intervention. So even the placebo group was able, in most studies, to increase synthesis rates. So even without the provision of food or amino acids, we saw increases.
Yeah, but if you would have like a whole body 1 hour resistance training program, would then the demand be higher than with just squatting?
Yeah, I do think that the demand would be higher as more muscles are active. Well, yeah, we focused on the legs as we took the muscle biopsies from that area.
But that doesn't really matter where you measure it. It's just you want to increase the demand.
Yeah.
Even there's only one spot where you measure it.
Yeah.
The demand is increased everywhere.
Yeah, no, I totally agree with that, that if you train your whole body, there's more of a demand. But in that case, the body would also be in need of more amino acids. And in our studies, we actually showed that there's no effect of providing additional protein or collagen specifically. So I don't think that it would have an effect on our outcomes.
Okay. Second question I have is on the proteomics. The number one hit or protein you always find is titin. Do you know why titin always pops up first in proteomic data?
Also here, like I'm not a proteomics expert, but I hope I give a sufficient answer to that. So I do think it's the case as titin is one of the largest molecules we have in our body. So I think it's just difficult to miss.
Mm-hmm. What type of protein would you qualify titin?
It's definitely a tricky question. I think there might be a debate out there. It depends on who you ask. I think it's not specifically a contractile protein, as it's not contracting by itself, but it's in my opinion, it's more classified as a connective protein that is transferring the force.
Yeah. Could you go back to one of the slides where you showed a contractile protein fraction? Yeah, that for example, on the left top. Can you explain what? Yeah. Because not everyone is aware of what that image really shows.
Yeah. So you actually in that image you see titin as well as like this small spring. So it is part of the sarcomere, and that's also the case for many other connective proteins. So what we separated is not sarcomeres versus collagen or membranes. What we try to separate is contractile proteins, so actin and myosin that basically slide into each other, compared to all other kind of proteins that build a structure or transfer a force around the sarcomere. So in this case, titin is part of the sarcomere, but I would still classify it as more like a connective protein.
Yeah, I don't agree, but the spring, what connects? What proteins does this spring connect?
It's connecting. Now I'm challenged myself. So it's connecting the myosin to actin, and if the sarcomere is being stretched, the titin molecule is also being stretched, and if the whole sarcomere is being pulled together, titin is actually helping with that. So
it's actually creating movement as an elastic recoil. I mean, exactly. You cannot be much closer to contractile function than I mean, there's only one protein probably that has more to do with contractile properties, and that's myosin. And then a second up for me would be titin, even though we agree on this, I mean, nomenclature on sarcomeric or contractile, but I think it's contractile.
Okay, yeah. No,
but what's in a name, right?
Exactly.
Yeah. Good. My third question is on tryptophan. You see tryptophan depletion in some of your conditions, which makes sense because there's absolutely no tryptophan in collagen. Are you aware of the physiological consequences in the hours, in the time range of hours, when tryptophan gets depleted in the body and it gets really low in the plasma?
Yeah. So first of all, I'm not fully aware of like the metabolic or like clinical consequences of a low tryptophan availability. So.
It's a precursor of serotonin. Are you aware of that? Yeah. There's a neat technique. You shouldn't try it at home, but if you want to get depressed, you have to eat a lot of collagen for a couple of hours as the only protein source, and then your tryptophan goes down, and then you get depressed.
We didn't see that with our participants.
Did you check it?
we didn't see any difference like between participants, at least from my own experience. So I don't expect it. No.
Yeah. The mood would not really affect the muscle protein synthesis, but maybe the dietary intake would. Would you think that tryptophan and serotonin are related to dietary intake, food intake, post-exercise?
I think so, because they're probably, I'm also not too aware of that, there are protein sources that are much higher in tryptophan. So if you have protein sources which are higher in tryptophan, they would also deliver and provide more tryptophan for the circulation. And therefore it's a precursor for the whole body as well.
But the combination of no tryptophan and a lot of other large neutral amino acids even competes for the entry of tryptophan in the brain.
Yeah, but I would never, because we did it in our studies to check it, to investigate it, but I would never advise to only take collagen. So that's what we did in chapter 4 and 5. So for me, it's seen more like as an additional protein to other protein sources, because we definitely do not want to limit or even deplete specific amino acids like tryptophan.
I completely agree. Thanks a lot.
Thank you, Professor De Raven. The opposition will be continued by Professor Sale, Professor of Human Physiology and Nutrition from Manchester Metropolitan University in the UK.
Thank you, Madam Prorector. Dear candidate, I echo my colleagues' words. You've done a fantastic job here. It's a really interesting body of work, and I'm honoured to be able to have read it and then come to this opposition. So, congratulations on getting to this point. Of course, like everybody else, I also have some questions, which is why I'm here. One of the things I was quite interested in is that you've used in some of your studies both male and female participants. And that's really to be highly commended. I think that's exactly the way we should be going. But of course, that does raise some potential additional questions. And so one of the questions I've got at the start is, in your studies, did you look at whether there was, perform some sort of sensitivity type analysis to look at whether there were any differences between the responses in your male participants and female participants?
Dear highly esteemed opponent, thank you for the nice words as well, and thank you for the question. I totally agree that it's important to conduct research with men and women, and we actually did perform some sensitivity analysis or checking between sexes. However, in most our publications, it wasn't added as wasn't part of the statistical analysis plan, while now chapter 3 has been just accepted, and there we added analysis or results on sex-based differences. And there we actually see that females show a higher basal muscle protein synthesis rates for the myofibrillar, but also for the muscle connective protein fraction. And then therefore, the response to exercise and nutrition is lower. So they at baseline, they're higher, but they respond less.
Okay, so the next logical question is, why do you think that is? What do you think is the mediating factor for that?
Yeah, so that's also a discussion we had, and that's definitely nothing I can fully answer on spot. So my explanation is definitely based on speculation. So one might be that it's based on hormonal levels. However, I don't think that's like a large contributing factor. And another factor might be the load that has actually been applied for these participants, as men are usually stronger and therefore like a higher load on the muscle has been applied.
Yeah, which makes some sense. I mean, so going back to your idea around the hormonal levels, you measured largely across the early follicular phase, if I recall, so somewhere between days sort of 0 and 7 of the menstrual cycle.
Exactly.
So obviously at that point, initially estrogen concentrations would be pretty low anyway. But one of the things that we do see is over time, certainly over 7 days, probably from about 4 days onwards, the estrogen concentrations do start to rise quite rapidly. So even within your female participant pool, did you see any variability in terms of, or did you even look at, of course, variability according to either estrogen concentrations or according to cycle length of the individual?
We did not measure estrogen or other hormonal levels per se, so I can't really give you an answer to that. And then next to that, if there was a larger variability in females, just based on what I looked at the data points, at the scatter plot, I do not see much larger variability between men and women within that sex category. So I think there's quite a variation between men and women, but within the sex, variation is fairly similar.
So obviously that's presumably because you're indicating it's fairly well controlled within menstrual cycle phase. So, exactly. So do you think there might be
you mean over the menstrual cycle?
Well, that's my next question, I suppose, in a way, is whether you then think there is any value in looking at whether differences across the menstrual cycle might be apparent.
So there's definitely a big difference in terms of hormonal levels. However, it has just recently, I think it was end of last year, it has been published that the menstrual cycle phase does not have an effect on muscle protein synthesis rates. That's based on mixed or myofibrillar protein synthesis rates. However, I don't think there's any differences with the muscle connective protein. So I don't think it's a leading factor there.
No, great. Neither do I, so we agree. So moving on to my second question then is a little bit about some of your extraction protocols. So obviously I think I take chapter 3 as an example. You say that the pellet that's created has both mature and immature collagen in it. So from an extraction point of view, what is it, first of all, you think that's being measured there directly?
So you mean now in the pellet? So I think that's also highlighted in chapter 6. So I'm sure that there's a bunch of proteins present, and there's again identified in chapter 6. So I think it's all kind of connective proteins, and like we also showed, it's definitely not just collagen. So of the collagen itself, it might be immature and mature, but since we know it's only 5% of the whole fraction, it probably doesn't have much of an effect on that fraction.
So you don't think that sort of influences potentially the outcome of the results in any way?
I don't think so, because the content of collagen within the muscle connective protein fraction is just too little.
Too low. Yeah.
If we would go for only collagen, then I think it might make a difference, but that's nothing we measured.
Good. So I guess my third question is in relation to sort of chapters 4 and 5, and picking up on some of the things that my colleagues have already sort of mentioned around the dose that you used of whey at 25 grams, and then the dose of collagen at 5 grams. And if we look at chapter 5, I assume that the rationale for that, as you presented there, is based upon chapter 4, where 5 grams of collagen was enough to maintain the plasma glycine availability. But of course, in your prior chapter 4, the dose response that you showed was you still get a greater plasma glycine availability with the higher doses. So again, can you just revisit again what the rationale for that particular split was? And then I've got some follow-up questions based on that.
I'm looking forward to these. But it's definitely something we had a lot of discussions on as well. So in my honest opinion, we don't know if that's the absolute perfect protein blend. However, testing all 4 conditions in a single study leads to all kind of difficulties, as you can imagine. So we had to choose for one protein blend. And we choose the 25-5 acid, like I also highlighted here, that it prevents a decline in plasma glycine. So there should be sufficient glycine availability, and there's no drop in availability. And on the other hand, it still provides large amounts of essential amino acids, which are probably the driving force to, first of all, stimulate synthesis rates based on nutritional factors.
Yes, so I mean, one of the other ways to go, of course, and then of course you're trying to match whey and the collagen supplement together, but obviously you've capped that in that initial study at 30 grams. So why cap at 30 grams? Why not go more with the you could even keep the same ratio or whatever, but you could go more.
Yeah, definitely an important point as well. But we want to stick with a more meal-based protein approach, which is usually always seen as 30 grams of protein. And in most other studies, or in many other studies before, it has been shown that 20 to 30 grams of protein might be sufficient to stimulate synthesis or muscle protein synthesis rates. Therefore, we kept it with 30 grams as the practical and what has been shown before.
Yeah, you've got to keep it practical somehow. So yeah, these are always questions that you can go back to. But I guess where I'm starting to think is a little bit outside of just your thesis with a focus on muscle. Is there a potential way in which whey could be used for the promotion of muscle alongside exercise, as you mentioned, but then maybe collagen's also provided for a focus more widely on other musculoskeletal tissues. So it's thinking about, tendon, ligament, bone, for example, where there may be a bigger effect than you've shown here for muscle.
Yeah.
There may not, of course. That's still yet to be determined. So under those circumstances, might we need a slightly different strategy? I guess what I'm asking is 5 grams of collagen under those circumstances likely to be enough?
So I think it really depends on what kind of situation you look at. So if you look at recovery from exercise, which is mostly targeted at the muscle and tendons, of course, but there's not too much tissue being broken down. So I think where larger amounts of collagen might be needed are situations where there's a lot of collagen being broken down inside the body. And I think that's something we try to discuss I try to discuss in the discussion and my general discussion. That might be, for example, healing after orthopedic surgery, or what I think might be really a good strategy or good outcome to look at is burn victims, as lots of skin is being broken down and needs to be rebuilt. So I think there, we don't know how much collagen we need, but I think that might be a better target compared to muscle. Yeah, I agree. So I mean, just following on from that, so do you think there is any?
Can you keep your questions short?
Yeah, sure. So is there any reason why you wouldn't be able to go higher amounts in total under those more specific circumstances?
I do think more collagen can be supplemented, but it shouldn't come on excess of other proteins. So even in these kind of conditions, I think we should first go for more the higher quality proteins to allow for the general need, and then additional collagen should always be on addition, and there it might be more. So it's not really harming us.
Okay, thank you. I'm happy with the answers. Back to you.
Sorry to interrupt you, but
no problem.
I want to give the word to the last opponent, Dr. Poffet, Assistant Professor at Maastricht University in Belgium.
Thank you, Pro-Rector, dear candidates. So I truly enjoyed reading all your work. And you mentioned me like an hour ago that you were afraid that Keith Barr would send me some questions, which he didn't, but I will start with a question related to his work. So in one of his studies, they supplemented people with gelatin and then took some plasma samples and added those to 3D engineered ligaments. And there they found an increase in collagen synthesis, which is opposite what you found. And what do you think is the reason of this different effect? Is it related to gelatin versus hydrolyzed collagen? Is it due to vitamin C? Is it the model? Or what do you think?
Yeah. Dear highly esteemed opponent, also thank you for your nice words and for the question, and I'm definitely aware of that study. And I think it's definitely an important question to discuss. And I think it's not due to the protein or collagen or glycine-enriched source you choose. And I also don't think it's, I don't think we're there yet that we can only link it to vitamin C. But I think it's really dependent on the model. So what we look is at connective protein synthesis in vivo in humans, while in that study engineered ligaments have been used where a high concentration of gelatin-enriched blood, so to say, so lots of glycine available, was directly put on these tendons. So it's easier for that tissue to get the specific building blocks, while inside the human body we have the circulation, and those nutrients first have to get to the tissue.
And what does this tell us about the rate-limiting factor for muscle connective tissue protein synthesis? Is it then the content of amino acids? Is it the transport, or is it something in the fibroblasts itself?
That's again a good question. I can't give you a definite answer on that because I think we need more research for that. I do not think it's the availability of amino acids, because in our bloodstream, what we showed in our studies, there's sufficient in our ideas, there's sufficient precursors available. So it might be limited based on the transport into the muscle cell or into the tissue that is being synthesized. And it might be, which I'm not an expert in as well, linked to fibroblast activity.
Okay, thank you. Then related to, so the studies all focusing on resistance exercise, and our lab is more into endurance exercise. So as you know, the extracellular matrix is also linked to, for instance, muscle angiogenesis, and also collagen ingestion can increase glutathione and impact oxidative stress. Do you think that there is any potential benefit of collagen ingestion for endurance exercise, especially the adaptive response?
Yeah. So in that case, it's difficult to say. I do think that there might still be a beneficial effect of collagen ingestion. However, I do think it's not as big for muscle, and I would still agree that it's also the case for or after performing endurance exercise. And if there's an effect, I would still more link it to precursor availability.
And so now all the focus is on muscle protein synthesis, but there are some other mechanisms that can be impacted. So for instance, there's a study showing that collagen ingestion improves sleep, which is also important in recovery. Can you identify like 3 key mechanisms by which collagen might improve recovery, except for protein synthesis?
Yeah, definitely a tricky question. And first of all, I would like to say that if we look at the body of literature, there's a lot of studies that show really beneficial effects of collagen, but most of these studies lack a protein control group. So we often see positive effects with collagen ingestion, but that's compared usually against the placebo. So we don't know if it's actually the collagen effect or a protein effect. So I think that's the main message I would get or bring across here. And then in terms of like how collagen can be beneficial for the human body, like you mentioned, like glycine can be a promoter of sleep or falling asleep. And then besides that, glycine can also be or is a precursor for other molecules or substrates inside our body, for example, creatine. So I think glycine in our bloodstream can also be beneficial to play a precursor for other substrates. However, again, I would state that it's easier ways, for example, to get creatine by just supplementing it directly. So my opinion is that collagen is more providing building blocks for tissues.
So then my next question focuses on how we define protein quality. So there are different concepts available.
Yeah.
And how would you define protein quality related to then muscle connective tissue?
Yeah. So I think protein quality is definitely a big debate about that, and I think it will never end. But it's usually based on the amino acid composition. So it depends on for what kind of tissue you want to use it for. So if you really want to promote collagen synthesis, I think then dietary collagen is maybe a bit higher ranked, as it provides the correct building blocks. But our body is made of so many proteins. So even if we want to target collagen inside our body, we also need other amino acids for the support of other tissues. So in that case, I would still go with the argument that collagen is a fairly low quality protein. And again, what I also mentioned with Professor Sayle's question, it should be on addition to other proteins.
Mm-hmm. Then a last question, I think, so focusing on glycine. So when you look at all the time curves, there's always an initial peak and then it rapidly decreases. Do you think there can be any benefit of having like a slow release collagen to have like a continuous increase in glycine and that might impact synthesis?
Again, I don't think it would have an effect on muscle, because what we showed in our studies, that is not really responsive to glycine availability. So I also don't think it's more prolonged availability that is really providing the much bigger benefit here. But again, it might be beneficial for other structures. For example, if again, like going in the direction of burns, it might be beneficial to have prolonged glycine availability. And that might be via slow-releasing collagen or ingesting small amounts of collagen every certain times of period. So that's, I think it can be beneficial, or could be beneficial.
That was about perfect timing.
It was planned like that. That's why I took it short at the beginning.
Thorben Aussieker, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. I request that you and your company await the results of our deliberations and our return in this room.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Long road to the south side, 7 miles in my rearview mirror. I know what it felt like. My goal's only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. On the line, I know you know that I can't read your mind. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile. Long road to the south side, 7 miles in my rearview mirror. I know what it felt like. My goal's only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Take the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. And even though these nights seem long, I know that I am never on my own. Know you've won the battle once you've grown. South side, 7 miles in my rearview mirror. I know what it felt like. My goal's only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. Long road to the south side, 7 miles in my rearview mirror. I know what it felt like. My goal's only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and die. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile.
Thorben Aussieker, the degree committee here present has assessed the quality of your thesis and your defense. In view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Professor van Loon is authorized to confer upon you this academic distinction in accordance with Dutch university custom. I invite your supervisor to now take the floor.
Do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent and responsible?
Yes, I promise.
By the authority invested in us by law and in conformity with the decision of the committee here present, I hereby confer upon you, Thorben Aussieker, the degree of doctor and grant you all rights attached by custom and law. As evidence of this, I now present you with the degree certificate signed by the rector, the secretary and the other members of the committee and affixed with the official seal of the university.
Okay. Dear Dr. Aussieker.
Hello.
Ready for this?
Nope.
Dear Thorben.
I'm just happy that Luke is not doing that.
Don't worry, don't worry. So when I was preparing this little speech that we always do after a PhD defense, I was thinking about how to start it. Because we kind of made you, at least, to pronounce your title of your PhD defense in Dutch during your presentation. So I thought it would only be fair to also start my speech with a little bit of German. So, hold on. Wir sind unglaublich stolz darauf, wo du heute stehst. Und du hast es dir diesen schönen und wichtigen Tag in deiner akademischen Laufbahn verdient.
Well done.
That's all I could get, get all the German for me. So,
that's enough.
But the fact that you're here today, having successfully defended your thesis, is the result of a long and challenging journey you've undertaken. And you know, PhD research is not a sprint, but it's a marathon. And you know what you promised me?
No.
But I will get back to that towards the end. It's always important to thank, and Professor Goosen already mentioned that you had a quite, it's always important to thank the people that helped you to come to this, to get this point. And Professor Goosen already mentioned that you have quite an extensive thank you note in your booklet, which I think is a really nice thing that you've done. But I think you missed somebody, and that's my wife. If it wasn't for her, we would not have met, and this whole day maybe not even would have happened.
True.
And I can see a puzzled face now, so I'm going to very shortly explain why I think you need to thank my wife for this. So I went back to your original email that I could still find in my inbox, which was on September 20th, 2017. You sent me an email that you were looking for an internship position, and one of your teachers, Crystal van Gol, recommended you to contact me. And this internship was part of a 2-year research master, which in my mind was to train epidemiologists. And the reason why I thought this is because my wife did the same research program and became an epidemiologist. So when I saw your email seeing a student requesting an internship position from this research master, my first response was, no. No, 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 this is not going to happen. One epidemiologist in my life is more than enough. So too bad, no internship position for this guy. But strange enough, you wrote something really strange in your email. Nothing like what a traditional epidemiological researcher would mention. You were interested in exercise and biology. So that raised some suspicion to me. So I told my wife, Anna, the epidemiologist, about it. And in the first instance, she laughed. But then she convinced me to at least invite you for a meeting to discuss the possibility for an internship. But I think she thought it would just be funny that there was a remote possibility that I had to work with an epidemiological student as an internship. So I told my wife, okay, I will invite him, but if he starts talking about statistically wanting to model muscle physiology or exercise or whatsoever, I will kick him out immediately. So I invited you for a conversation, and to my surprise, the conversation was nothing alike. No talking about statistically modeling. You even had wet lab experience in working with human muscle biopsy samples. To this day, I still do not understand why you completed a research master program, but in the end, after our conversation, I thought, this might actually work. And your internship started a few months later, and so you kind of have to thank my wife for actually taking you on as an intern to even talk to you. During your internship, you worked on muscle biopsy samples from Cass's bed rest study, evaluating muscle satellite cells, a little bit different topic from this, during which you already showed high degree of independence, working on a new microscope technique that we set up, and you managed the analysis quite independently yourself. And this resulted even in a publication of your master thesis. It took a while, but in the end, it was published in Journal of Applied Physiology. During that time, you already expressed your desire to pursue a PhD in our research group, and your work did not go unnoticed by other members from the research group. And at that time, we were aiming already to start a new research line on collagen, collagen protein. But funding for the PhD project was not immediately in sight. So as an interim solution, we decided to give you a chance by performing an acute exercise study in which you evaluate the anabolic properties of the collagen in a first initial study. So this is a study that you performed together with Luc Hilkens, also in the audience, and which in the end became the first study of your dissertation. You successfully completed the recruitment and data collection for this study and showed how all-round you were and ready to take on a full PhD position in our research group. So Luc and I and other members from the research group, we invited you, right Luc, We invited you to join the research group to work on a number of studies evaluating the anabolic properties of collagen protein ingestion, which was co-founded by TKI Health Holland and also some industry partners, Shalita and Tassendalo, which in the end resulted in the dissertation that you defended here today. And today is not the first time that you presented actually your work. You presented at many different conferences, which you already received many recognition for the work with a lot of Young Investigator Awards at ECSS, at ACSM. You also had several awards at German conferences, exercise physiology conferences. And performing all this work is not without its challenges, of course, as you have experienced, and especially because you have a daily commute from Cologne towards Maastricht and back. It's not always easy to make all ends meet, especially if you have a lot of test days starting early in the morning, finishing late at night, so you frequently crashed at your colleagues' couch to make ends meet, and that's already showing your commitment. But this was not even challenging enough for you, because you and Connie decided to extend your family with the lovely arrival of little girl Maxie, of course. And I know firsthand what it's like to have a newborn around in the final years of your PhD, which can be a whole different type of challenges. But in the end, you made it all work, which is a true testament to the commitment and the work that you have performed. Within the research group, we have seen you grown from being an intern towards an independent scientist on which we others can rely. Your willingness and commitment to others is always showcased by the fact that beside the papers that you include in your thesis, you have an additional 12, 13 co-author or first author publications that you worked on as a result from your time within the research group. Towards the end of your PhD, you already decided that you would like to continue your scientific work at the German Institute, a topic that we frequently discussed, which also brings a lot of insecurity about how can I find a new job, young family, that's always challenging, of course. But Luc and I had no doubt with the build-up of your resume within our research group that people will be willing to support you in that. And you made it work. And you managed it by securing a postdoc position at the Technical University of Munich, where you continue to work on collagen protein as well. So congratulations on reaching this important milestone. And this I would like to include also your family, your parents, your wife Connie, little Maxie, of course, as well as your friends and colleagues in this achievement. So on behalf of myself as well as Luc, I would like to thank the assessment committee here present today for their reviewing of the dissertation and making this day possible. And a special thank you to our international guests, Professor De Rave, Professor Seel, as well as Dr. Parfait, for their willingness to be part of this review committee and to be present here during the ceremony. Dear Thorben, be proud of what you have achieved over the past years and enjoy this day. And I hereby officially relieve you of your promise to me that you would run a city marathon before finishing your PhD. All the best in your futures. Thank you so much.
Well, dear Dr. Aussieker, also on behalf of Maastricht University, I would like to congratulate you with the degree you have acquired today. Of course, I also congratulate your family, friends, and colleagues. Many of them I already heard 2 times, 3 times. I also congratulate your supervisors with this degree. And I'd like to thank the members of the degree committee for the work they did in preparing for this defense and being here during the defense. Special thanks to our members from outside Maastricht University, Dr. Parfait. Difficult to remember your name. Professor De Rave and Professor Seel, thank you very much for being here, for your contribution. Maastricht University really appreciates that. Hopefully, you will also look back on this event with great satisfaction. We're not too nervous, I hope.
Worked.
It's work.
Which is really warm.
But now it's time to relax and enjoy the rest of the day with friends and family and colleagues. And with this, I close this academic ceremony.
You got a clap. You got a clap. Take it.